similarity in right triangles. So we have something that's called the geometric mean. So the geometric mean of two positive numbers is going to be the positive square root of their product. Okay, so it's going to be the positive square root of their product. Okay, so you're always going to use the positive square root for this. And basically, here's what the equation is going to look like. The geometric mean would be the x. We know that product means multiply. So A and B are going to be your two positive numbers. And then this is going to be the square root of the product of those two numbers. Okay, so this is how we can represent our geometric mean. What we're going to do now is find the geometric mean of each pair of numbers. And then we are going to make sure that our answer is in simplest radical form. Okay, so we're finding the geometric mean, and then we're going to write our answer in simplest radical form. So for part A, we're given 4 and 25. Okay, so 4 and 25, that's going to be our A value and our B value. Okay, so if I think of A as 4 and B is 25, when I set this up, I'm doing x equals 4 times 25, which we know is what? 100, right? 4 times 25 is 100. So the square root of 100 is what? 10. So we're always using the positive. You don't have to worry about the plus or minus with this. So your geometric mean for 4 and 25 is going to be 10. Okay, so I'm going to give you a few seconds to set up B. And you can see B is already a little different. So Jared, what did you get when you multiplied 5 and 30? 150. And if you take the square root of 150, are you going to get a nice whole number like we did with 100? No. So then we have to write this in simplest radical form. So remember, you want to find the perfect squares that go into 150. Okay? And what's usually the lowest one that you would start with? 4, right? Because it's 2 squared. So does 4 go into 150? No? Okay, so what would be the next one we try after 4? 9. Does 9 go into 150? Okay, are you checking them or are you just telling me? Okay, so let's check them. Okay, 16. Do you know how you would know that 16 wouldn't go in there? Because 4 doesn't go in there and 4 goes into 16. Okay, what's the next one that we would check? 25, okay, let's see if 25 goes in there. Yes. Yeah, how many times? 6. So we can think of this as the square root of 25 times 6. I know that that's the biggest perfect square because are there any perfect squares in 6? No. 4 is the lowest one, and if I tried to divide it by 4, I would get a decimal. Okay, I wouldn't get a nice whole number. So when you split this up, I want you to know that what you're doing is you're taking the square root of these separately. Okay, so when you do this, sometimes people just mess up on what comes outside and what stays inside. When you take the square root of 25, what do you get? You get 5. There's no roots there anymore. But the square root of 6 has to stay. Okay, so your final answer is going to be 5 square root of 6. Okay, and that's how you find the geometric mean. All right, so you guys ready for the back? Okay, so the next thing we're going to look at are the geometric mean corollaries. So I'm just going to highlight this. So the geometric means. what we're going to be doing with this is finding lengths in similar right triangles. Sorry. Okay, so we are finding lengths in similar right triangles. All right, so let's analyze what this first corollary is trying to tell us. So it says the length of the altitude. So try to remember back a few chapters about when we talked about an altitude. An altitude is also another name for what? The height, okay? And if you have the height of the triangle, what normally accompanies that? I mean, with the height. Like, how would you know which one of these is an altitude? Tony?
The box for a 90-degree angle.
Okay, so you're going to have a right angle next to it, okay, for the altitude. Remember, there are multiple altitudes for one triangle. Okay, so you are going to see that it is a right angle. So the length of the altitude to the hypotenuse of a right triangle, so it has to be a right triangle, is the geometric mean of the lengths of the two segments of the hypotenuse. Okay, so what this tells us is that h squared here is going to equal xy, which really, let's put this in the same form we did before. How could I just solve that for h? Take the square root. So I would have h equals the square root of xy. All right, so I want you to pay attention to where these are in the picture. So we have h. H is going to be the altitude. Okay, and we can see that because you do have the right angle here. Okay, and it's the altitude of the hypotenuse. Okay, remember your hypotenuse is going to be across from the right angle in a right triangle. Okay, so we can see that this is a right triangle. Okay, we can see that this is the hypotenuse, so this is the altitude from the vertex to your hypotenuse. Okay, and then it says the lengths of the two segments. So here are your two segments of your hypotenuse. This is your x, this is your y. That's where it's coming from. Okay. Now, for the second part, the length of a leg of a right triangle is the geometric mean. So I'm going to, the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent to that leg. So we're going to do a couple of things here. The first thing is let's write this as the geometric mean as well. So A is the square root of x times c, and B is the square root of y times c. So we're going to try to make sense of this a little bit more. So it says the length of the leg of a right triangle. Okay, so here's one of the legs of the right triangle. That would be A. This is a leg. And then also B is a leg, which is why we have two equations here. Okay? So the length of the leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So if you look at your picture, okay, C is the hypotenuse. If C is the hypotenuse, can you guys see how that's part of the geometric mean for both of them? Now this one has X and this one has Y. Those are very specific. You can't just interchange them. It's because it says it's going to be to the segment of the hypotenuse that's closest to it. Okay, so pay attention. So look at A. Can you see how A is closer to X than it is to Y? It's right next to X, the side X, it's touching it. Same thing with this. Your B is right next to your Y. Okay, so that's how you're choosing which part of that is. Now, you might not always just get that side C. You might just get X and Y. So if you were trying to find C and all you had were X and Y, keep in mind that C is going to equal your X value plus your Y value. Okay, so you can always add those together. Okay, now the triangle can be flipped upside down, to the side. There are lots of different ways that you can see that this right triangle. So a couple things to keep in mind is that the hypotenuse is always across from the right angle. So hypotenuse of a right triangle is always across from its right angle. Notice that there's two right angles in here. One of them is for the whole entire big triangle that you have here. That's what's making it a right triangle. Okay? Remember that the legs of a right triangle make up the right angle itself. Okay, so here's my right angle. And I can see that A and B are constructing that right angle. Okay, so now what we're going to do is try example 3. So example 3, we're going to find the side lengths in right triangles. Okay, and this says to find your X, your Y, and Z. When you are solving these, we're going to solve this in alphabetical order. Okay, sometimes what you're going to have to do is look and see which one you can solve for. Okay, so for this, we're going to solve in alphabetical order. Which in this case is X, Y, Z. All right, so the first thing that we're going to try to do is find X. Okay, and if you need to like label what different parts are, that's absolutely something that you can do. This is your right angle, which lets you know that this side is going to be your hypotenuse. So if I want to find X, okay, X is part of my hypotenuse. Okay, I know what my altitude is which is really helpful. Because my altitude, I know if I use up above that my h equals the square root of x times y, I can set up something similar. Right? So above, if I use h equals the square root of x times y, remember that the h was your altitude. Right? So basically what this is saying, if I were to write this out in words, this is the altitude equals the square root of the product of the hypotenuse segments. So the two segments that make up the hypotenuse are what and what? 9 and x, good. And then my altitude is 6. Okay, and again, if you want to label that as your altitude, you can. Okay, so what we have is that 6 is going to equal the product of 9x, and that will be inside the square root. So what I want to do is solve this for x. So if I'm going to solve that for x, what would I do to both sides? How do I undo a square root? Square it. And I'm going to write that in the next step. So you can square both sides. 6 squared is going to be 36. And then when you square the square root, you're just left with what's underneath. Okay? And then you're going to divide both sides by 9. Okay, so then your x value is going to be 4. Okay, the next thing that we're going to find is y. Okay, now what part of the triangle is your y? Good, yep, it's your leg. Okay, so all we have to know is it's a leg, because then we can solve using one of these two equations. Okay, so if you're finding y is a leg, so we use corollary 8-1-3. Okay, which tells us that the leg is the geometric mean, and I'll write this out in words again, in case you are having trouble. So the leg is going to equal the square root of the length of the hypotenuse times the segment of hypotenuse closest to the leg. Okay, so if my leg is y, I'm going to set up y equals, so what is the length of my hypotenuse?
13.
Okay, yes, so you knew that x was 4, right? Because your hypotenuse is x plus 9. So if you know that x is 4, x plus 9 is going to be what? 13. Right? So when you're plugging that in, I'm going to plug it in as 4 plus 9 first, just so you can see where that's coming from. Okay, and then you're going to multiply that by the segment that's closest to the leg. Right? So now we know that this is 4. Is y closer to 4 or closer to 9?
4.
It's closer to 4, so then we have to multiply it by 4. gonna do z in a little bit, and I want you to think about how we would set that up. Okay, so this will be 13 times 4. Right? Now, normally, what I would do is I would multiply that out, but you're trying to write this in simplest form. So, wouldn't this be the square root of 4 times the square root of 13? Can I just rearrange those? Instead of 13 times 4, I can do 4 times 13? Because what's the square root of 4? 2. So this is going to be 2 square root of 13. Okay, now if you already multiplied, you would have got the square root of 52, but because we're writing it in simplest form, you would have went right back to this. Okay, so if you can simplify it without multiplying, you can go ahead and do that. All right, and now we're going to find z. Do you guys think you can set this up to find z? Okay, so z is another leg. Okay, so you can set this up to find your leg. I'll give you a second. Let's see. Okay, so I want you to set up what you think the equation is, and then just check it with your elbow partner. Okay, and it's okay if it's wrong.
No, it's not.
I'd rather have you make your mistake now. Okay, so when you set up. So if z is a leg, are we using the first equation or the second equation to help us? The second. Okay, so z has to equal the geometric mean of, and it's going to be the same thing that we did here. So it's the length of the hypotenuse, which, what did we find was the length of the hypotenuse? 13. And then it's multiplied by the segment that's closest to it. So your two choices for the segments are 4 and 9. See how those are the only two segments that make up the hypotenuse? So which one are we going to multiply by 13 for this? 9. Now we're going to multiply by the 9. Okay, so again, it doesn't really make sense for me to multiply that out, because can't we already see what my perfect square is here? Yeah, so what I would do is I would just rewrite it as the square root of 9 times the square root of 13. And what's the square root of 9? 3. So it'll be 3 root 13. Okay, if you are having trouble, like with the first one, if you can't seem to find it, see if you can set up one of the equations for the other one. Okay, so sometimes you might not be able to find the altitude first. You might have to find a leg first. Okay? Alright, so your homework from 8.1 is going to be 5 through 12.
Do you know what page?
I don't have the page.